Hi, everybody. Welcome to episode 2 of For Crying Out Loud. This time we're going to tackle global winds, which are the major movers of weather on Earth. Before we do that, you need to know that extreme cold, like the air at the poles, is going to create high pressure. That's because cold air is very dense and the molecules are really close together. So because it's so dense, it's going to be heavier. That's why cold air sinks. So on a global scale, that means that a cold air mass pushing down on Earth's surface is going to be heavier. That's why we get the term high pressure. Now, in contrast, extreme heat, like the air at the equator, is going to create low pressure. Warm air is less dense because the molecules are farther apart. If the molecules are farther apart, it's going to be lighter. That's why warm air rises. So on a global scale, that means a warm air mass is going to rise above Earth's surface, and it's going to create less pushing down. And it's going to be lighter, so that's why it's considered low pressure. So what does that have to do with wind? Well, warm air rises and cold air sinks. So air is always going to move from an area of high pressure, where it's cold or cooler, to an area of low pressure, where it's warmer. And the greater the difference between that high pressure and low pressure is where you're going to get stronger winds. So if we go back to the lava lamp that we did with the volcano unit, you'll see that warm wax is going to rise. And the warm wax rises because it's less dense, its molecules are farther apart. That would be like a low pressure system. When it rises, the cooler wax is going to take its place because it's a high pressure system. The molecules are closer together and it's going to sink. So that means that wind is a convection current. You can see from this diagram, that's what happens on Earth. Warm air from the equator, which is low pressure, is going to rise towards the poles. And colder air from the poles, which is high pressure, is going to sink and move towards the equator. That creates global winds. Now, in between the global wind belts, you have global pressure systems. These pressure systems, or differences between highs and lows, are what create the wind belts that are in between them. So at the poles, you have the polar high. Those are at 90 degrees. It's very cold and dry there, and you're going to have cold air that's going to sink towards 60 degrees north and south. And those are represented here and here. The next thing you have is the polar front. The polar front's at 60 degrees north and south. You get a cool, moist air mass, and the difference between this low pressure center and the high pressure center at the poles is going to create a wind band in between. The next band you have is the Subtropic High at 30 degrees north and 30 degrees south. You're going to get warm, dry air there, and the area is going to move towards the equatorial low. They're located here and here, and they're also called the horse latitudes. And finally, at the equator, there's the Intertropical Convergence Zone, or the ITCZ. And it's an area of warm, moist air, and it doesn't have any winds. And they call it the Doldrums. Now, in between these high and low pressure areas, you're going to get wind bands on Earth. And that's what's going to move weather in that area. So, you can see between 90 and 60, you have what are called the Polar Easterlies. They move from east to west. Remember that all winds are named by where they come from. And They move between 90 degrees and 60 degrees at the polar front. This next section is the westerlies. And you can see they're between 60 and 30 north and south. And they're called the westerlies because they move west to east. And they're between the polar front and that subtropical high. So you've got a low pressure and a high pressure system. The last set of global winds are the trade winds. And they move from east to west. They're also called the easterlies. And they're between the horse latitudes and the doldrums, between the high pressure center and low pressure centers. Now, we're in the United States, specifically Michigan, so we're between the polar front and the subtropical high, and that's what dictates our weather. Our wind band is the prevailing westerlies, and that means that generally all of our weather moves from west to east in the United States. Now, you can also correlate those to the climate zones we already learned about. So you have the polar easterlies are where the polar climate zone is. In the temperate zone where we live, we have the prevailing westerlies. And in the tropical region, you have the trade winds. So the polar zones are here. This is the temperate zones. And right here are the tropics. So I'm going to show you this video from Moo Moo Math and Science for a quick recap.
Welcome to Moo Moo Math and Science. In this video, you will learn about global winds. The Earth is not heated evenly. Warm air rises and creates low pressure systems, and cold air sinks and creates high pressure areas. This rising and falling of air creates 6 large wind sails spread out around 30 degrees around the Earth. In addition, the Coriolis effect, which is the curving of the winds due to the Earth's rotation, impacts global wind patterns. First, polar winds. These begin near the north and south poles. Cold air in the winter sinks towards the ground, creating a high-pressure area at the poles. Winds form as they move from high-pressure area near the poles towards the low-pressure areas 30 degrees below. These winds blow from east to west. The next global winds are the prevailing westerlies, and they blow from west to east. These wind belts are found between 30 degrees and 60 degrees latitude in both hemispheres. The westerlies can carry moist air over the United States, producing rain and snow. Next are the trade winds. Between 30 degrees north and 30 degrees south of the equator, in an area called the horse latitudes, the Earth's rotation causes air to slant towards the equator in a southwesterly direction in the northern hemisphere and a northwesterly direction in the southern hemisphere. The Coriolis effect, in combination with an area of high pressure, causes the trade winds to move from east to west on both sides of the equator. The trade winds of the northern and southern hemisphere meet in an area around the equator called the Doldrums. In the Doldrums, there is very little wind because the warm air rising creates an area of low pressure. And finally, the horse latitudes are located at about 30 degrees north and 30 degrees south. Sinking air creates an area of high pressure, and as a result, the winds at these locations are weak. These areas are called the horse latitude because, according to legend, this name was given to these areas when sailing ships carried horses from Europe to America, and when the ships were stuck in the windless area, horses were maybe thrown overboard to save drinking water for the sailors. Remember, this is just a legend.
Okay, So one final thing I wanted to show you from the last video. On the day of the spring equinox, you can see that there were more hours of daylight than there were of night. That's because we are now approaching the summer solstice that will happen in June. So every day we will be gaining minutes of daylight because the sun is moving on its tilt. So I wanted to show you the difference between last week and this week, and you can see there's a difference in the numbers of how many hours of daylight and night we're getting. These two numbers aren't alike at all, and there are more hours of daylight than there are of night. So, we have some questions to think about. Extreme cold creates which kind of pressure system? Extreme heat creates which kind of pressure system? How many global pressure systems are there on Earth? How did the horse latitudes get their name? Which pressure belt contains most of the world's deserts? How many global wind belts are there on Earth? Which wind belts match up to the tropical climate zone? Which wind belts match up to the temperate climate zone? Which wind belts match up to the polar climate zone? And finally, how many more minutes of daylight than darkness are we getting in our area? I've attached a Google Doc to this video, and you can write your answers right into it and submit it right back into the Google Classroom rather than email me. So I'll leave you with one last thought. Yeah, I know it was bad. Anyway, stay well, be safe, and know that I miss your faces. I hope we'll be able to get together soon. Talk to you later. Bye.